hands. Hello, everyone. Thank you for being here. I am Shaundai Person. As Flor mentioned, I'm a senior software engineer at Netflix. And today we'll be talking about Remix as a browser framework and interactivity and performance and all the beautiful things that Remix does for us. So when we talk about a performant app, what we typically mean is an app that our users can see and interact with as quickly as possible. And performance metrics measure essentially this. Like, let's take Google's performance metrics, for example. Metrics like largest contentful paint and first input delay all help us to understand how quickly, when a user comes to your site, are they able to see what they expected to see and do what they expected to get done. Now, Remix gets us to a higher level of performance by getting your users to interactivity much more quickly. So first, what is interactivity? Interactivity is the relationship between your users and your app. And that could mean a number of things. It could mean what happens when they push a button or click a link. It could mean when they make a comment. How quickly can they see that in the UI? And the hooks that listen for the comments on the comments and tally the likes on those comments. Remix gives us tools right out of the box that allow us to get to a much more performant app by getting your users to interactivity much more quickly. Whether your users have high-speed internet or whether they are stuck in the airport without their luggage in Brussels, not a specific story at all, they're able to have a much more pleasant experience. Remix does this by adopting some of the properties of both client rendering and server rendering. So we're going to take a second and we're going to talk about the difference between the two. Remix will adopt the best parts of each. So, client rendering. Client rendering, if you're using a framework like React, Vue, Angular, your app is client-only rendered by default. Client-only rendered means that it's rendered by the client. All of the instructions to run your code are held inside of a JavaScript script tag. When a browser receives a request for a page, the page sends the HTML, the CSS, and the JavaScript over to the browser to be run. The browser parses the information, runs the JavaScript, loads and runs the JavaScript code. And then from that point, your site becomes interactive, meaning it's usable. Videos will play, modals will open, the whole nine, right? The thing is, if your app has heavy amounts of JavaScript, like most apps these days do, or if your user is stuck in Brussels with slow internet connection, it can take some time before that JavaScript is loaded. That means it takes some time before your app is visible by your users, never mind interactive. And until that JavaScript is loaded, all your users are going to see is a blank page. Keep in mind that this is only for the case of initial page render, because once we have hydrated, we store the JavaScript and the assets in memory, and then we can retrieve those. And so as we're navigating between routes in our app, it seems almost lightning fast, almost instantaneously interactive, because we're just refreshing the DOM with the information that's already been stored. It's only that initial page load, that's the problem. So here's where server rendering comes in. And server rendering is considered an optimization on top of a client-rendered app. And server rendering is actually the way that we've done it since the dawn of man, like back when the cavemen were coding in languages like PHP and C#, right? So server rendering, y'all like that, right? An app so server rendering, it doesn't solve the problems of like slow internet connections or large JavaScript bundle sizes. But what it does do is it gives your user something to look at while that JavaScript loads. So a typical app using server rendering works in this way. First, on the server, we are going to fetch the data for the entire application. And then also on the server, we will generate HTML from your React components, and we will send that over to the browser to be displayed in the screen. So already at this point, your users are having a much better experience because the JavaScript hasn't been loaded yet, but they can already see the content on your page just as static HTML. Keep in mind, though, server rendering alone is not enough to give us a complete site because, yes, your users can see the content on your screen, but they can't interact with it yet, aside from some basic HTML things that we've put in there, which a lot of us don't spend a lot of time doing. So we do have to move on to the next step of loading our JavaScript. So that's the next step is on our client, we'll load the JavaScript for the entire application. We'll attach the logic to the HTML that's already in the browser. This is called hydration. And then after it's been hydrated, your app is fully interactive, where you get the videos playing, the modals opening, things like that. So again, server rendering is considered an optimization because on initial page load, your users have something to look at. The catch, though, is that with server rendering, every time we navigate to a different route, we have to run through that process all over again, and all over again, and all over again. So to a user, it may seem like a little less performant than a client-only rendered app. So here we have this trade-off, right? Do we want these lightning-fast transitions between pages, even if your users are going to have to sit and wait for that initial page load and see that blank screen? Or do we want that HTML displayed in the DOM so that your users don't see that blank screen, even if it means we're going to have to run through the server rendering process all over again every time? Well, what if we could have the best of both worlds? Remix gives us the tools to use, as we're navigating between routes, to use the benefits of a client-rendered app, and also adopts the properties of a server-rendered app on that initial page load. So let's talk about how we do that. First, here's our app. It's written in React, so our outermost component is a layout, which has two children, a nav and a sales pane. The sales pane has two children, a header and an invoice list, and then that invoice list has one child, which is an invoice. And this is what the app will look like in the browser. So if you've ever been to Remix's website, this probably looks a little bit familiar to you. This is similar to their example, Fakebook's website, just a simplified version of that. And this is what your users are going to see. So again, Remix is going to adopt the properties of a server-rendered app on initial page load. So first, let's talk about that initial page load. We'll go back through the steps of server rendering and talk about how Remix is not only going to give you a server-rendered app on that initial page load, but it's going to give you an optimized server-rendered app on initial page load. So let's talk about those optimizations. The first step of server rendering is where we're fetching the data. And how this works with our app is we're going to, on the client, make that request, and then on the server, we're going to fulfill that response. So we will walk the component tree, and we'll fetch the data in the order for the components as they appear in the tree. We'll send that back as the response, and then we can move on to the next step of the server rendering process. There's two issues with this. And the first issue is that our logic to request the data is on the client. And this is a really big pain point for that hypothetical person who can't find her luggage, and it's stuck in Canada, and she's in Brussels, and she has no internet, and she's trying to find out where her bag is. So if your user has slow internet connection, think about it. We're making this request on the client, and then it goes over to the server, and it has to make the round trip back. And so if your user has slow internet connection, and we're sending over a lot of data, it can cause some really laggy performance, and it blocks us from moving on to the next step. We can't control how fast our user's internet connection is, but we can control how much we send over the network. So let's illustrate this problem. Let's say with our Fakebooks app, we want to flip the page just from invoice A to invoice B. Nothing's going to change about our app except for just this information about invoice B. The header is going to stay the same. The nav is going to stay the same. On the client, we're going to make this request, and we're going to say, hey, server, I need the information for invoice B. And so on the server, like this is the request. I'm the request. So I'm going over to the server, and then the server hears it, and the server's like, oh, OK, cool. You want the information for invoice B, right? Well, the way that this API is set up, I have the information for invoices A, B, C, D, all the way through Z. And I also have some information about the user that's going to go in the header. So here you go. I'm going to send that all over. And we're going to send all this data over the network. And this user is stuck in the airport, remember, and she has really slow internet connection, and she's just sitting there waiting, and frustrated about her bag being stuck in Canada. She's not a real person, by the way. And we're sending this back over to the client. So it causes several painful moments for your user who can't see any of the bare HTML in their screen just yet. The next issue is that we're doing something called component fetching. And this stems from the way that we have to walk the component tree and fetch the data for the components in the order that they appear in the DOM. So in our app, we have to first fetch the data for the layout, then fetch the data for the nav, then fetch the data for the sales pane, and then fetch the data for the sales pane's children. And so it kind of looks like this in this waterfall effect. It's like a relay race where one component fetches its data and then has to pass the baton to the next component so that they can initialize their fetches. So there's two kind of sub-issues here. One is that parents are blocking their children from initiating fetches, meaning the children, in this example, let's say the invoices can't initiate their fetches until the invoice list has come back. And so if invoice list takes a long time for that data request to be fulfilled, that child has to wait until it comes. And so the user in their screen, they don't see the invoice that they were looking for. This is the most important information. All they see is the loading spinner. Now let's use this in a real world example. Let's say that you go out to eat with your kid, and your kid has to sit there and watch you finish your meal before they can even get served. Problematic, right? The second sub-issue is that the components that take a longer time to fetch elongate the entire process because we have to fetch one by one. So it acts as kind of a bottleneck, like the sales component, for example. It acts as a bottleneck for the entire process and causes the process to go for a long time. Remix gives us the tools to fix this. So first, rather than put our request logic on the client, we're going to move it to the server. So now on the client, we're still making that same request. We're saying, hey, I just want the information for invoice B, please. And the server now has the information. Rather than sending that full backpack of information over the network, your server can say, OK, cool, like I have all the information that you would possibly need, but I'm only going to send you the information that you need rather than everything else. So let's go back to our example. And now you see the server has a little brain because it can think. So on the client, we'll do this again. I just ran this morning, so thank you, Debbie. On the client, we will say, hey, server, I need the information for invoice B, please. And then there's a request. And the request goes over to the server, and the server says, hey, you know what? I do have a lot of information. I see you, girl. I know that you only want the information for invoice B, so I'm just going to send over this dainty little bit of information, and it's just going to dance over the network, and then we'll bring it over, and your user is much more happy because they don't have to wait all that time for the information to come through. The second thing is that now that we're not doing component fetching, we're doing something called route fetching. And this is fundamental to the way that Remix works. So remember before, we had this whole waterfall relay race, pass the baton thing going where we had to fetch the data for each component one by one. I'll talk about how route fetching works. And Remix is actually based on React Router. So you're going to see some similarities if you're familiar with React Router. So each component in your React app is coupled with an aspect of the route. So notice how the colors are changing as they correspond to the different components, right? Remix knows, so each component is coupled with a piece of the route. Each component has its own fetching logic, and they're all separated from one another. That means that we can run these in parallel. So now, this is what our data requests look like. We can do it all at the same time. And now our process is only as slow as the slowest component. So it moves a lot faster, and it shortens the process altogether. And now we can more quickly move on to our next step of rendering our app as HTML in the screen. So this is the stage where your users are able to see some of the content on the screen. And it's a benefit from the server rendering perspective because your users aren't looking at that blank screen, even though the JavaScript hasn't loaded. But the way that we do it with traditional JavaScript frameworks is problematic. And it's because if we're using a JavaScript framework, obviously your app is heavily concentrated with JavaScript. It can take a long time for that JavaScript to load. Remix, by contrast, is a browser framework, is a web framework. And it uses the foundations of the web as the foundations for the framework. And by the foundations of the web, I mean browsers, HTTP and HTTP caching, plain old HTML. And browsers have become much more advanced in the past 20+ years, so there's a lot that you can do here. So the difference for your users is that normally, with a regular JavaScript framework, they have this HTML, but it's not interactive. Aside from what? Like links? What else do we put into HTML? Now users have a lot of ways that they can work with your app and interact with it. So, and one thing, as a caveat, I am a React developer. I'm a JavaScript woman through and through. I'm not saying to throw out your JavaScript. I'm just saying that there's a lot of things that your users can do with bare HTML with Remix. You can even actually turn off JavaScript and still have a fully functional app. So JavaScript is just kind of like the seasoning on top, if you will, just a little sprinkle on top. And so as a result, your browser has a lot less JavaScript that it has to work with, which we will talk about now. So we move on to the next step of loading the JavaScript. And Remix gives us a lot of tools out of the box to make our app compile down to less JavaScript. So you're actually going to be using less code in your app. If you think about it, with any JavaScript framework, we typically have a ton of code that's attributed to data manipulation, data fetching, handling errors, loading, and things like that. So we're going to talk about how Remix provides us right out of the box with tools that we can use to just have less JavaScript and make the step move a lot slower. So this step, we load the JavaScript. And how this works is that on the client, we rather than, this is the HTML that's being displayed in the DOM, rather than wipe all this out and repaint the DOM with new DOM nodes, we use the DOM nodes that are already in the browser, and we just attach the JavaScript to the HTML that's already in the DOM. This process is called hydration. And then once this process is complete, your app becomes fully interactive and your users can use it. Okay? So again, remember that in your standard React app, Angular app, Vue app, a lot of your code is going to go into handling data requests, handling errors, accounting for loading states. Let's take this simple form, for example, and this is a simple form. There's really two inputs, and it's running off of the page. So this is a very simplified form. We're fetching data, we're accounting for loading, we're accounting for error states, and it goes off of the page. Remix, by contrast, gives us APIs right out of the box so that that same form comes to this. So when it comes down to compile time, when it comes for your time for your browser to load the JavaScript, there's a lot less that it has to work with. And so this step can move a lot more quickly. And now we move on to the next step, which is hydration. So again, we're just attaching the JavaScript to the HTML and the DOM, and then we hydrate. And so this is the point where your app becomes interactive. And because we have shortened the process at every stage, we've actually made your customers a lot happier. Their app is interactive a lot more quickly. Now remember, though, this is for initial page load. So after we hydrate, we're going to store the JavaScript and the assets in the browser's memory and cache. And this is really important because this is the part where Remix starts to adopt the properties of a client-rendered app. So we're going to shift over to navigating between routes. Now, when you're using a typically server-rendered app, we're going to have to make that full round trip every time we navigate to a new route in your app. Remember, Remix is going to store your JavaScript and your assets in memory. So rather than making that full round trip with a backpack of information, we're only going to first check the browser's cache and memory to see if that information's already been pulled, and pull it from right there if it has been. All right, so then navigation between routes is lightning fast. So let's go back to our example. Remix, remember, and this is an aspect of route fetching. Remix can look at the URL now and can tell, as we're navigating between routes, what's going to change between those routes. So Remix can see that, all right, if I flip to another invoice, the only part of this screen that's going to change is this invoice 500. The invoice list isn't going to change, the header is not going to change, the nav isn't going to change. So I'm just going to update, I'm just going to take, and actually the UI doesn't even change. So if you think about it, like all that's going to change is really the numbers. So rather than fetch the data for the entire application, rather than remove all of the JavaScript and CSS from the DOM, we know the CSS is going to look the same from page to page. So all we'll do is we'll fetch the data just for the invoice 501, that's going to change, refresh the DOM with the JavaScript and the CSS that's already stored in memory, and then we instantly have an interactive app for your users to see. So again, adopting the properties of a client-rendered app on navigation between routes. Now, haven't gotten to the best part yet. Because Remix has your component asset manifest, meaning that just by looking at the route, it can tell the CSS, the HTML, the JavaScript, the data that's going to be needed for your app. All Remix has to do is hover or see your user hover over a link, and it can start prefetching. So you just add this prefetch prop to any link, And Remix will understand, okay, hey, I see Shaundai is hovering over this part of the invoice. I know what information is going to be needed. I'm going to go ahead and get those assets ready. So Remix is acting kind of as a concierge. Real world example, let's say that you're looking at a shoe website and your significant other is looking over your shoulder, sees those expensive shoes, and is like, you know what? Looks like she's interested in that. I'm gonna go buy her 5 pairs. And I'll have that ready for her. And so by the time you're ready to walk out the door, your shoes are already there. So Remix is there for your users in advance. All right, and that is that. If you want to find more about Remix, they have excellent documentation on the Remix website. Also, one thing that I've loved is Ryan Florence on YouTube has snippets of code examples and use cases that you can learn from to try more. So feel free, deploy freely, and ask questions if you want to. Thank you.